Hello everyone, thank you for the amazing introduction. Are there any horse riding enthusiasts here? Okay, not many. But imagine if you could feel every exciting jump, every thrilling race, and every smooth ride as it happens, no matter where you are. At Clip My Horse, we tackle the challenge of delivering real-time video streaming experience to our users with WebSockets. And today I will show you how we achieve that, why we are using WebSockets, and I will also show you how WebSockets can be implemented in React Native app. As you already heard, I'm Violina Popova, software developer at Clip My Horse and co-founder of Frontend Queens, online community supporting women in frontend. Now let's see what this company for horses is doing. Clip My Horse is the leading provider of live equestrian sports broadcasts. We deliver the equestrian world to the screens with our mobile, web, and smart TV platforms. Annually, we stream 2,500 events from over 40 countries, reaching millions of horse enthusiasts around the globe. At our Clip My Horse Academy, riders can access high-quality training videos, enhancing their skills and knowledge. Our digital auction and marketing platform enables riders and horse owners worldwide to actively participate in the most significant horse auctions globally, or to market their horses successfully. And every year, we have more than 4 million unique users. In the world of equestrian sports, timing is everything. Riders and fans demand instant access to live streams where every second counts. Imagine, for example, in show jumping, which is a discipline in the equestrian sports, even a single missed ride can cause competitors to lose the competition. Also, buffering and debugging can affect the viewing experience, whether it's watching live commentary competition or bidding in the online auction. And there are a few challenges which are important to take into account when we talk about real-time streaming, and the first one is latency. Streaming thousands of events to millions of users requires seamless updates, and also the viewing experience should be seamless. Also, streaming thousands of events to millions of users requires a robust infrastructure. Imagine, for example, watching your favorite horse missing the finish line first due to a lack in the stream. And interactivity. Users expect to interact with the content seamlessly, whether it's live commentary, bidding in the online auction, or accessing on-demand events. And with all that being said, HTTP is less than an ideal solution for applications that require immediate real-time updates. And in order to provide seamless experience to our users, we need a reliable solution that can deliver real-time updates instantly, and that's where WebSockets come in. In the context of equestrian world, using the WebSocket protocol, we can establish a two-way bidirectional communication between the client, like the mobile app, and the server. This way, our users don't have to refresh the mobile app constantly in order to receive the updates from the server. Instead, they can, as soon as competitors' data is in or new live event has started, we can send the updates from the server to the mobile devices instantly. Before I dive deep into how WebSocket works, I want to make a comparison between two fundamental methods of data transfer, the WebSocket protocol and HTTP, and see their differences and similarities. As we all know, HTTP is the traditional way for transferring files such as text, images, sound, video, or other multimedia over the web. It works as a request-response mechanism where a client sends a response to the server sends a response back, and the connection is closed. It is also important to mention that HTTP requests are stateless. They trigger each request individually, and this means that there is no continuous connection between the client and the server. As you can imagine, all this increases the overhead on the server, and this requires a lot of resources. On the other hand, we have WebSockets, a protocol for bidirectional connection between the client and the server over a single long persisted connection. As I already mentioned, using WebSockets, we can send updates to the mobile devices instantly, and this doesn't require our users to refresh the mobile app constantly, as this would be the case if we were using HTTP. The WebSocket protocol has its unique URL scheme, and this is WS for unencrypted connections or WSS for encrypted connections. And we all know that for dealing with hypertext, we use HTTP or HTTPS. Now let's see how WebSocket works. In order to start the WebSocket protocol, the client sends a request to the server, which triggers the handshake protocol. The HTTP handshake protocol is used to communicate with the WebSocket protocol in the in the abridged header. Once the WebSocket connection is established, we can send messages to the client, and messages can be in the form of plain text or binary data. And actually this information can be sent seamlessly over a single TCP socket. And the last part of the life cycle of the WebSocket is termination. When this can happen by either the client or the server, depending on the need of the application, and when we receive the request to close the connection, it is terminated. Why we at Clip My Horse decided to use WebSocket? The first reason is low latency, which, as I already mentioned, is important. Every second counts in the request transport, and we cannot, as an application which has million users, we cannot afford application which is which has delays in the streaming experience, and with WebSockets we achieve this low latency. Also efficiency. Unlike the traditional HTTP protocol, WebSockets are more efficient in terms of network and server resources. And bidirectional. Already mentioned that we can send messages from client to the server or either way, and this doesn't require continuous iteration of the connection or request response mechanism. Now let's see how at React Native application we can implement WebSockets. So React Native supports WebSockets, and there are 4 main functions which can be triggered: on open, on message, on error, and on close. These functions are triggered when the app establishes a connection, receives a message, catches an error, and disconnects. The first thing which we have to do when we want to establish a WebSocket connection is to create the WebSocket object. And in React Native, we can do it by using this code. And here, the URL should point to the WebSocket service running on the backend. And as I already mentioned, WebSocket uses its own protocol, which in our case is WSS for encrypted connection. Once we have created the WebSocket object, we can trigger the onOpen function, which means that connection is open, and at this stage we can send any information which can be sent one time to the server. For example, I will show you how our onOpen function looks like in our app. Once the connection is open, onWebSocket connection started is triggered, which sends subscribe action to our server, and also we are sending one-time data like user ID and the channel ID. This means that the user which has started the stream will be connected to specific channel ID which is related to the stream. Now that we know how to create the connection, let's see how we can receive messages from the WebSocket server. And in order to do that, we can use the onMessage function. In our case, with the onMessage function, we are checking different events for our application. The first one is duplicate. I will show you later on what exactly the duplicate event do in our app, but we are also checking for different functions, like the init event, horse details. Actually, these functions are pretty much longer in our app. This is just fragment how it looks like. This is how we are handling the init event in our app. And as you know, the WebSocket messages can be in form of strings, plain text, or binary data. In this function, we are decoding the data received from the WebSocket. We are parsing this data and also transforming, and we are making sure that the transformed data should be displayed in the user's locale. If for some reason there is an error on our app, either to poor internet connectivity or internal server error, the onError function will be triggered, and this will initiate the connection termination by triggering onWebSocket connection ended. And the last part is the termination itself, which is happening with the onClose function. Here we are debugging the reason for the closed connection, and we are allocating the resources with onWebSocket connection ended function. The purpose of WebSocket service at Clip My Horse is to detect duplicate account usage in our app, and also to send additional data for the live streams. Duplicate account usage means that if the logged in user has started the stream from one device, and we receive information that the same user has started the stream from different device, the first started stream will be terminated, like in this case, and this message will be displayed on the player. This way we are preventing multiple account usage from one account, one registration, because this is a subscription based service, and in this case, WebSocket is useful for us. The WebSocket service is implemented in Node.js and is hosted at AWS as one of the functions. I won't display this in details because I'm not a backend developer. And while the WebSocket service provides seamless account usage in our app and enhance the video live streaming experience for our users, there is another application which takes the experience for our broadcasters to the next level, and this is the Cockpit application. Here, for security purposes, I have hidden some of the information, but this is how the cockpit panel for the currently running live streams looks like. Here we can see all the information about the currently running stream, like the channel to which user will be subscribed, the competition title, also the event name, and if we select specific event, we can see all the additional information for the currently running stream. And if we open the injector, we will see the detailed panel for the currently running stream with all the information which our broadcasters can add to this stream, like the starter list. For example, this starter list corresponds to the starter list which is displayed in the mobile app, and it provides information for the current competitor and horse. And the data which we are sending for the competitor and the horse is called Q points in our application. So also we can insert advertising with the cockpit and any other additional information which is needed. I've received this question many times yesterday, and I decided to include it into my presentation. So why we are not using WebRTC? Actually, both protocols, WebSocket and WebRTC, has their strengths and are suitable for different scenarios. As we heard from all the amazing speakers yesterday, WebRTC is best choice for peer-to-peer communication, like video conferencing. But in our case, in order to provide real-time updates for the currently running streams, WebSocket is the preferred solution. So that's why we are not using WebRTC. And with all that being said, I just want to say a big shout out to all the amazing people working at Clip My Horse Product Tribe. The success of our application couldn't be possible without all of them. So all the amazing individuals decided to be shout outed. And that's all. Thank you so much.
Violina, and we already have some hands rose up over there, I think. Where are the microphones? Are they anywhere? They are coming. Okay. Where was it? Oh yeah, over there.
I had a question about the streaming part. Are you using WebSockets only for signaling an API, or are you also transferring the media itself via WebSockets?
Sorry, could you repeat louder because I couldn't hear the question?
Is this on?
Yeah.
Okay. Yeah. Are you only using WebSockets for the signaling and the API only, or are you also transferring the media streams via WebSockets as well?
Well, in our case, it's mostly used for signaling and API.
Any other questions from anyone? I have a question out of curiosity. I assume that in this weird, to me at least, world of equestrian sports, there are events less and more popular. I'm curious, what is the highest peak viewers you've ever seen in your app?
Well, I'm not prepared with this data, but usually when there are big events like some world championship, we have peak with a lot of users using the application at the same time.
And do you scale the infrastructure dynamically when things like that happen? You expect the burst of interest, or?
Yeah, actually, before such big events, we are making some precautions to make sure that our app won't crash during some important event. For example, a few months ago, there was a big championship in Germany, Aachen, and our app didn't crash during this event.
Good for you. Okay. Oh, yeah, there is a question in the back.
As a follow-up to the first question, so if you're not using WebSockets for transferring the media, how do you transfer it between the client and the server? Maybe I missed that part, but...
Well, I won't dive into this detail because I'm not backend developer, and I only operate with the part where I receive the messages from the WebSocket, and the respective data is displayed on the mobile app.
Okay. And are you thinking of experimenting with Quick as well?
Yeah, actually, since Lorenzo spoke yesterday, I think that Quick could be a good protocol for our case, but this should be discussed with the backend developers in our team.
Good. Thank you.